There's something haunting about the way the universe reveals itself to us, not in straightforward answers, but in layers of mystery that unfold the deeper we look. Every time you gaze up at the stars, you're not just seeing distant points of light, you're peering into a cosmic time machine. The light from those stars has traveled for years, centuries, even millennia to reach your eyes, meaning you're witnessing them as they were in the past, not as they are now. Some of those twinkling lights might already be gone, their final glow still racing across the void toward us. It's a humbling thought, isn't it, that our entire understanding of the cosmos is built on echoes and afterimages, a universe that constantly slips just beyond our grasp. But that's only the beginning. The more we learn about space, the more it feels like stepping into a surreal dream where the rules of reality bend and twist. Take the silence of space, for example, a vacuum so complete that sound simply can't exist. No screams, no explosions, just an infinite, eerie quiet. Or consider black holes, cosmic monsters so dense that not even light can escape their grip, warping time itself in ways that defy logic. And then there's the sheer scale of it all. Our galaxy alone contains hundreds of billions of stars, and yet it's just one of countless others in an expanding universe that might stretch on forever. The numbers alone are enough to make your head spin. This video is a journey into those unsettling truths, 22 facts about the universe that will challenge everything you think you know. Some will fill you with wonder, others might send a chill down your spine. But one thing's for certain, by the time we're done, you'll see the cosmos in a whole new light. So take a deep breath, because we're about to dive into the unknown, where the familiar laws of physics twist into something strange and beautiful, ready to have your mind stretched to its limits. Let's begin. Imagine standing in a room where 95% of everything around you, every chair, every wall, even the air itself, was completely invisible. That's the unsettling reality of our universe. What we think of as the cosmos, the stars, planets, and swirling galaxies, makes up a mere 5% of existence. The rest, a cosmic ghost story written in dark matter and dark energy, two invisible forces shaping the universe while remaining utterly mysterious to us. Dark matter is the universe's hidden scaffolding, an unseen gravitational glue holding galaxies together. Without it, stars would fling apart like scattered marbles. We know it's there because we can see its gravitational fingerprints, the way galaxies rotate too fast, the way light bends around empty space, but we've never directly caught it. It doesn't emit, absorb, or reflect light. It's a shadow passing through walls, a whisper we can't quite hear. Then there's dark energy, far more bizarre and elusive. It's not holding the universe together. It's tearing it apart, pushing galaxies away from each other at an ever-increasing speed. Think of it like an unstoppable force stretching the fabric of space itself, as if the universe is being inflated from the inside. And here's the unsettling part. The more the universe expands, the more dark energy seems to grow, making this acceleration unstoppable. Scientists have spent decades chasing these phantoms, building detectors deep underground, launching telescopes into space, all trying to catch a glimpse of the invisible 95%. Yet for all our technology, the true nature of dark matter and dark energy remains one of the greatest unsolved puzzles in physics. It's a humbling reminder that we're still strangers in our own universe, surrounded by forces we can't see, barely understand, and may never fully unravel. We're all familiar with gravity's pull, the way it keeps our feet on the ground, and the moon orbiting Earth. But what if I told you there's something out there, something unseen and colossal, tugging not just on our planet or our solar system, but on our entire galaxy and thousands of others with irresistible force? Welcome to the mystery of the Great Attractor, a gravitational anomaly so powerful it's dragging the Milky Way and its cosmic neighbors toward it at a staggering 14 million miles per hour. Picture this, you're in a canoe on a calm river when suddenly the current quickens, pulling you toward some invisible vortex downstream. That's essentially what's happening to us right now, but on a galactic scale. The Great Attractor sits about 250 million light-years away in the direction of the constellations Centaurus and Norma. But here's the eerie part, we can't see it directly. Our view is blocked by the thick dust and stars of the Milky Way's own galactic plane, leaving scientists to piece together its influence like detectives reconstructing a crime scene from scattered clues. What makes this cosmic tug-of-war even stranger is the scale of the forces at play. The Great Attractor isn't just pulling a handful of galaxies, it's at the heart of a vast flow of matter known as the Laniakea supercluster, a web of hundreds of thousands of galaxies all moving together like leaves caught in a river's current. And yet, even this supercluster's motion suggests something even larger might be lurking beyond it. A tapestry of dark matter and unseen structures weaving the universe together in ways we're only beginning to grasp. So what could this invisible titan be? Some theories suggest it's a dense cluster of galaxies, their combined gravity creating a focal point for everything around them. Others speculate it might be a concentration of dark matter, the universe's hidden scaffolding warping space-time itself, but the truth is we still don't know for certain. Every answer leads to new questions, reminding us just how much of the cosmos remains uncharted territory. Here's the most humbling thought of all. While we're hurtling toward the Great Attractor, it too is being pulled by something even more massive, an endless cosmic dance where gravity's invisible threads stretch across billions of light years. It's a reminder that no matter how much we learn, the universe always keeps a few secrets just out of reach, lurking in the shadows where the light hasn't yet reached us. Time isn't the steady, unchanging river we think it is. In fact, it's more like a stretchy fabric, warping and bending under the weight of the universe itself. Einstein's theory of relativity revealed a truth that feels ripped straight from science fiction. Time passes differently depending on where you are and how fast you're moving. Near a black hole where gravity twists space into knots, time slows to a crawl. Picture this, two astronauts, one orbiting close to a black hole's edge, the other watching from a safe distance. For the brave soul near the abyss, minutes might tick by normally, but for the observer, those same minutes could stretch into years, decades, even centuries. This isn't just theoretical, we've seen it happen on a smaller scale right here on Earth. Atomic clocks on GPS satellites, orbiting high above our planet where gravity's grip is slightly weaker, run faster than identical clocks on the ground. Engineers have to account for this tiny difference, or your phone's navigation would lead you miles off course. Now magnify that effect near something as monstrous as a black hole, and time doesn't just bend, it shatters into fragments. The implications are staggering. It means the universe has no universal now. Your present moment could be someone else's distant past or future, depending on where you're standing. A star exploding 10,000 light-years away might already be long gone by the time its light reaches us, but for civilizations orbiting near that star, it could be unfolding in what they consider the present. Time becomes fluid, a cosmic hall of mirrors where when is just as flexible as where. And here's the real mind bender. If you could survive a fall into a black hole, something physics says is impossible, but let's pretend you'd witness the entire future of the universe flash before you in seconds. As time stretched infinitely from your perspective, galaxies would bloom and fade like fireflies, stars would burn out, and the cosmos might even meet its end, all while you hovered at the event horizon. Meanwhile, anyone watching you from afar would see your descent slow to a frozen standstill, your image smeared across eternity like a ghost in the machine. This isn't just about black holes. Every massive object, planet, stars, even you, warps time around it slightly. Your head ages faster than your feet because it's fractionally farther from Earth's gravitational pull. The difference is imperceptibly small, but it's there, a whisper of relativity in everyday life. The universe doesn't just challenge our perception of time, it laughs at it, revealing a reality where past, present, and future might not even be fixed points, but ripples in a vast, shimmering sea of space-time. If you thought bending time was strange, wait until you hear about quantum entanglement, a phenomenon so baffling that even Einstein struggled to accept it. Picture two particles born from the same event, forever linked no matter how far apart they drift across the cosmos. Change the spin of one, and its partner instantly responds, as if they're whispering secrets faster than the speed of light. Einstein famously dismissed this as spooky action at a distance, but experiments have proven it's very real. We're talking about particles separated by thousands of light years reacting in perfect sync, as if distance means nothing at all. How does this defy everything we know? According to the laws of physics, nothing can travel faster than light. Yet entangled particles seem to break this rule effortlessly, communicating instantaneously across the void. It's like having a pair of magical dice roll, one in New York and the other in Tokyo, always lands on the matching number. No delay, no wires, no explanation. Scientists call this non-locality, an eerie connection that operates outside space and time as we understand them. The implications are staggering. If particles can influence each other across vast distances, it suggests the universe might be woven together by hidden threads, a cosmic tapestry where separation is an illusion. Some theories propose that entanglement hints at extra dimensions or a deeper layer of reality where all points are connected. Others wonder if this could one day revolutionize communication, creating unhackable quantum networks where information travels faster than light, though for now that remains science fiction. Here's where it gets even weirder. Entanglement isn't just a rare quirk, it's everywhere. The sunlight hitting your skin, the electrons in your phone, countless particles around you are likely entangled, their fates intertwined in ways we're only beginning to decode. And yet, try to use this connection to send a message and the magic collapses. The universe guards its secrets tightly, allowing us to witness the spookiness but never quite harness it. What does this mean for our understanding of reality? It challenges the very idea of separateness, suggesting that at the fundamental level, the universe might be far more interconnected than we ever imagined. Particles aren't just solitary actors, they're part of a vast, invisible dance, choreographed by rules we're still straining to comprehend. So the next time you feel alone under the night sky, remember even the tiniest pieces of the cosmos are somehow mysteriously in sync. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars and planets. Statistically speaking, the odds of Earth being the only place where life exists are astronomically slim. And yet, when we listen for signs of extraterrestrial intelligence, all we hear is silence. This unsettling contradiction is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Think about it, our galaxy alone could harbor millions of planets capable of supporting life. Some may have developed civilizations far older and more advanced than ours. They've had billions of years to spread across the cosmos, to build megastructures to send signals. So why, in all the vastness of space, have we encountered nothing? No radio transmissions, no alien probes, not even a single speck of evidence. Just the endless, indifferent hum of the universe. There are theories, some comforting, others downright chilling. Maybe intelligent life is exceedingly rare, an improbable fluke in a universe that favors microbes over minds. Or perhaps civilizations inevitably reach a point where they destroy themselves, whether through war, environmental collapse, or unchecked technology. It's a grim thought, but one that feels uncomfortably plausible given humanity's own precarious trajectory. Then there's the darker possibility. Something is out there, silently watching, ensuring we never make contact. This is the zoo hypothesis, the idea that Earth is deliberately isolated, either as an experiment or a preserve, or worse, what if we're simply not interesting enough? An advanced species might view us the way we view ants, too primitive to bother with. But here's the twist: the absence of evidence isn't necessarily evidence of absence. Space is mind-bogglingly big, and even a galaxy teeming with life might still leave us feeling alone. Signals could be lost in the noise, or maybe everyone's listening and no one's shouting. Some civilizations might communicate in ways we can't detect, using technologies beyond our understanding. Yet the silence remains unnerving, a whisper in the dark that makes us question our place in the cosmos. Are we the first, the last, or is the universe hiding something from us, a truth we're not yet ready to face? The Fermi Paradox doesn't just challenge our search for aliens, it forces us to confront the fragility of intelligence itself, and the haunting possibility that the greatest threat to any civilization might not be the stars but what lies within. Every story has an ending, but the universe's finale might be the loneliest one imaginable. Right now, galaxies are racing away from each other at speeds so fast that one day, they'll vanish over the cosmic horizon, leaving our night sky black and empty. This isn't just expansion, it's a runaway acceleration fueled by dark energy's mysterious push. Scientists call it the Big Freeze, the heat death of the universe, and it paints a chilling portrait of reality's ultimate fate. Picture this: trillions of years from now, the last stars will flicker out like dying embers. New ones won't form, galaxies will have exhausted their fuel, leaving behind skeletons of dead stars and black holes. Space will stretch so thin that even the remnants of once brilliant constellations will be ripped apart, their light stretched into meaningless, undetectable whispers. The temperature of the cosmos will plummet toward absolute zero, a cold so profound that even atoms slow to a near standstill. Here's the haunting part: time won't stop. It'll stretch endlessly forward in this frozen wasteland, with no events to mark its passage. Black holes, the universe's last survivors, will eventually evaporate in a faint burst of radiation, leaving behind only a sea of inert particles drifting further and further apart. No explosions, no rebirths, just an eternal, silent fade. But why is this happening? It all comes back to dark energy, that enigmatic force making the universe expand faster and faster. Think of it like rolling a ball uphill that grows lighter with every second. Eventually, it'll vanish into the distance, never to return. We're left with a cosmos where even the closest particles can't interact because space between them grows faster than light can bridge the gap. The irony is profound. The universe began in a fiery Big Bang, only to end in a whisper. No grand collapse, no cyclical rebirth, just an endless, dark expanse where even time loses meaning. It's a humbling reminder that all the beauty we see now, from swirling nebulae to glittering superclusters, is fleeting. The cosmos won't end with a bang, but with a slow, inevitable sigh of heat dissolving into the void. Yet there's a strange comfort in this. If the universe must end, there's poetry in its quiet departure: no violent collapse, no crushing singularity, just the gentle unraveling of everything into stillness. Perhaps in those final moments, the universe will finally answer the question that haunts us. It won't be about how it all began, but how softly it can let go. Now let's venture into one of the strangest ideas ever conceived, a thought experiment so unsettling it makes the average sci-fi horror plot seem tame by comparison. Imagine floating in the endless void of space, utterly alone, when suddenly, out of pure randomness, atoms collide in just the right way to spontaneously form a fully functioning, self-aware brain. No body, no history, no universe, just a lone consciousness blinking into existence, complete with fabricated memories and a vivid hallucination of reality. This is the nightmare logic of the Boltzmann brain. The theory comes from an eerie implication of thermodynamics. over unimaginably vast stretches of time, even the most improbable events can and statistically must occur. Given enough chaos, particles could randomly arrange themselves into complex structures, like a deck of cards shuffling itself into a perfect order by sheer accident. But here's the twist. Physicists argue it's astronomically more likely for a single, isolated brain to pop into existence this way than for an entire ordered universe like ours to emerge naturally. So if the cosmos truly lasts forever, Boltzmann brains should outnumber real biological minds by an uncountable margin. That raises a disturbing question. How do you know you're not one of them? Your memories, your sense of continuity, even the screen you're staring at right now. What if it's all an illusion, a fleeting ripple in the cosmic noise? Philosophers and scientists alike have wrestled with this. Some dismiss it as a statistical absurdity, while others admit we may never have definitive proof it isn't happening. After all, a Boltzmann brain would believe its reality just as fervently as you believe yours. The paradox cuts even deeper when you consider the nature of time. If the universe eventually reaches a state of maximum entropy total disorder, then perhaps the Boltzmann scenario is inevitable. In a lifeless, heat-dead cosmos where particles drift endlessly, the occasional brain might flicker to life, each one convinced, however briefly, that it inhabits a universe far richer than the void around it. So where does that leave us? Either we're living in a highly improbable but real universe, or we're momentary aberrations in an eternal sea of chaos. In the end, the Boltzmann brain thought experiment doesn't just challenge our grip on reality, it forces us to confront the fragility of existence itself. Maybe the most unsettling part isn't the idea that we might be illusions, but the realization that in an infinite cosmos, there's no way to ever be certain. Black holes aren't just cosmic vacuum cleaners, they're existential riddles wrapped in event horizons. One of their most baffling secrets is the information paradox, a puzzle so profound it threatens to unravel the very laws of physics as we know them. Picture this: you toss a book into a black hole. According to Einstein's general relativity, that book is gone forever, crushed into oblivion at the singularity. But here's the catch: quantum mechanics insists information can never truly be destroyed. Every particle, every page of that book must leave some trace in the universe's ledger. So where does it all go? This isn't just about books. Everything that falls into a black hole, stars, planets, even light itself, carries information. Quantum theory says that information is sacred, etched into the fabric of reality like ink on cosmic parchment. You can scramble it, hide it, but never erase it entirely. Yet black holes seem to do exactly that, erasing the universe's fine print without a receipt. It's as if the cosmos has two sets of rule books and they're fundamentally at odds. Physicists have wrestled with this paradox for decades, and their proposed solutions range from the elegant to the surreal. Enter Stephen Hawking's groundbreaking work. Black holes might not be the eternal prisons we once thought. They slowly leak energy, a phenomenon called Hawking radiation, evaporating over eons until they vanish entirely. But here's the twist: if the black hole disappears, what happens to the information it swallowed? Hawking initially thought it was lost forever, a conclusion that sent shockwaves through the scientific community. If true, it would mean rewriting quantum mechanics from the ground up. Then came the holographic principle, an idea ripped straight from the edges of science fiction. Imagine every bit of information that falls into a black hole isn't destroyed but smeared across its event horizon like a celestial fingerprint. The surface of the black hole becomes a scrambled archive, a two-dimensional projection of everything it's consumed. It's as if the universe keeps backups, storing data in ways we're only beginning to decode. But the paradox deepens. If information escapes via Hawking radiation, how does it retain its original meaning after being stretched, shredded, and reassembled? Think of burning a dictionary. The ashes still contain the book's atoms, but the words are lost. Black holes might be doing something similar, but with quantum rules demanding the words somehow survive the fire. Some theories suggest the information is hidden in subtle correlations between particles, a cosmic sleight of hand so precise it defies intuition. Perhaps the most startling implication is this: the information paradox isn't just about black holes. It's a window into the hidden grammar of reality itself, a sign that space-time and quantum mechanics are fragments of a deeper, unified language we haven't yet deciphered. Every time we peer into the abyss peers back not with answers, but with questions that stretch the limits of human comprehension. And that's the real paradox. The more we learn about black holes, the less we realize we understand. We like to think of the universe as stable, permanent, a fixed stage where the drama of existence plays out. But what if it's all just a house of cards balanced on the knife's edge of physics? This is the terrifying premise of the false vacuum theory, the idea that our cosmos might be a precarious bubble in an infinitely larger, stranger reality, and at any moment it could burst. Picture the universe as a vast, frozen lake. On the surface, everything seems solid, predictable. But beneath that ice lies supercooled water, a metastable state that seems stable until, without warning, a single crack triggers an unstoppable chain reaction, flash freezing the entire lake in an instant. That's the false vacuum. Right now, the quantum fields governing our reality appear calm, but they might only be temporarily settled, like a ball resting in a shallow valley. A nudge, say, a high-energy cosmic event or even random quantum fluctuations could send that ball tumbling into a deeper, truer valley, rewriting the very rules of existence. Here's where it gets chilling. If this vacuum decay happens, the change wouldn't just alter physics, it would erase it. A wall of destruction would race outward at the speed of light, rewriting reality as it goes. Atoms, forces, even the fabric of space-time would unravel into something entirely new. There'd be no warning, no time to react. One moment, the universe as we know it exists. The next, it's overwritten like a corrupted file, replaced by physics so alien that concepts like matter or energy might not even apply. You might wonder, how likely is this? The honest answer is, we don't know. Some theories suggest it's already happened elsewhere, that beyond the observable universe, patches of true vacuum could be expanding like ink drops in water, their borders invisible only because they haven't reached us yet. Others argue the odds are vanishingly small, that our universe has survived for billions of years, making sudden collapse statistically improbable. But probability offers cold comfort when the stakes are this high. The terrifying beauty of the false vacuum is that it reminds us how little we truly control. The laws of physics aren't just unchanging commandments. They might be local ordinances, temporary rules in a single neighborhood of a multiverse with infinitely shifting foundations. And here's the ultimate irony. If vacuum decay began, we'd never see it coming. The wall of annihilation would move too fast for any signal to outrun it. The last thing any conscious being would perceive is the universe, their thoughts, their memories, the very concept of existence, a flickering out like a candle in a hurricane. No sound, no spectacle, just an instantaneous, silent rewrite of reality itself. Yet there's a strange solace in this cosmic fragility. It forces us to confront the fleeting nature of everything, not just stars and galaxies, but the fundamental constants we take for granted. The universe isn't just in space and time, it is space and time, and both might be far more fragile than we dare to imagine. So the next time you look up at the night sky, remember, the stability we rely on isn't guaranteed. It's a momentary grace, a cosmic sigh between one breath and the next. Right now, as you read this, the moon is inching away from Earth at the same rate your fingernails grow, 1.5 inches every single year. It sounds negligible, an almost laughable distance on the cosmic scale. but this slow retreat is rewriting Earth's future in ways that would make even the most stoic climate scientist shudder. The moon isn't just a pretty orb in our night sky. It's the silent guardian of our planet's stability, and its gradual departure will unleash chaos over time scales so vast they defy human imagination. Think of the moon as Earth's gravitational anchor. Its pull doesn't just create tides, it acts like a cosmic counterweight, steadying our planet's axial tilt. Without that balance, Earth would wobble erratically, like a spinning top losing momentum. Mars, with its puny, scattered moons, offers a grim preview. Its axis can tilt by over 60 degrees, triggering wild climate swings that turn polar ice caps into equatorial deserts over millennia. Now imagine that instability here. Seasons would become unpredictable, with temperatures swinging between extremes. Ice ages might arrive and vanish in geological blinks, disrupting ecosystems faster than life could adapt. Here's the cruel irony. The moon's retreat is driven by the very tides it creates. As ocean waters bulge toward the moon, Earth's rotation drags that tidal bulge slightly ahead, tugging the moon forward in its orbit like a parent pulling a reluctant child. That tug transfers energy, pushing the moon farther away while slowing Earth's spin, lengthening our days by fractions of a second each century. Billions of years from now, Earth's day could stretch to a sluggish 47 hours, while the moon hangs so distant it appears smaller than Venus in our sky. But long before then, the consequences will cascade. With the moon's grip weakened, Earth's axial tilt could swing wildly between 10 and 40 degrees. Today, that tilt, a steady 23.5 degrees, gives us reliable seasons. A few degrees more or less, and agriculture collapses. Crops fail as growing zones vanish. Coastal cities drown under tidal surges or wither in droughts. Civilization as we know it relies on climatic stability the moon provides, and we're passively severing that lifeline. Yet the most unsettling thought isn't the chaos itself, it's the inevitability. Unlike climate change, which we might mitigate, the moon's drift is unstoppable, a celestial clock ticking down to a future where Earth becomes a different planet entirely. And for any far future descendants, if they still walk this altered world, the moon will be a diminished relic, its once mighty pull just a whisper in the dark. They might gaze up and wonder, did our ancestors even notice it slipping away? So the next time you see the moon hanging low and luminous, remember, it's not just a fixture. It's a fugitive retreating 1 inch at a time, taking Earth's golden age of stability with it. And while we won't live to see the worst of its absence, the universe is patient. It plays the long game, and in that game, even the slightest drift can rewrite destinies. We often picture the Big Bang as a cosmic explosion, a single fiery point blasting outward into empty space. But here's the twist, that mental image is completely wrong. The universe didn't expand from somewhere, it expanded everywhere at once. There's no central crater, no ground zero where it all began. Instead, space itself stretched like an infinite loaf of raisin bread rising in the oven, with every raisin, that is, every galaxy, moving away from every other raisin as the dough expands. No matter which raisin you're standing on, all the others appear to be racing away from you, creating the illusion that you're at the center. This means if you could teleport to a galaxy 10 billion light-years away and look around, you'd see the exact same thing we see from Earth, every other galaxy fleeing from you, as if you were the focal point of the universe. It's a cosmic magic trick, a flaw in our intuition. We're wired to think in terms of explosions having a center, a firework, a bursting balloon, but the Big Bang wasn't an explosion in space. It was the explosion of space, rewriting the rules of where and even what here really means. The implications are dizzying. If the universe has no center, then every point is functionally identical in the grand scheme of things. Earth isn't special, nor is the Milky Way, nor any other speck in the cosmos. the idea of a preferred location dissolves into the void, leaving us adrift in a democracy of emptiness where no place holds privilege over another. Even time bends to this principle. The further we look into space, the further back we see in time, meaning our observable universe is just a bubble limited by the speed of light. Beyond that bubble, countless other observers might be gazing at their own version of the center, each as cosmically insignificant as we are. Here's where it gets even weirder. The universe might be infinite, stretching forever in all directions. If so, no matter how far you traveled, you'd never reach an edge or a boundary, just more galaxies, more space, more of the same endless pattern. An infinite universe can't have a center by definition, because infinity has no middle point. But even if the cosmos is finite, it could curve back on itself like the surface of a balloon, making the very question of a center meaningless. You can't point to the center of a balloon's surface, only its three-dimensional interior. Similarly, the universe's center might exist in a dimension we can't perceive or access. This revelation doesn't just humble us, it redefines our place in existence. For centuries, humans believed Earth was the literal center of creation, only to be demoted to a mere planet orbiting an ordinary star. Now we learn there's no center at all, just an ever-growing fabric where every thread has equal claim to being the heart of the tapestry. The universe isn't expanding away from us. It's expanding around us, inviting us to let go of the need to be at the center of anything. In the grand dance of space-time, we're not the lead dancers, we're just one step in an infinite routine. What if everything around us, the stars, the trees, even the very thoughts in your head, weren't real, not in the philosophical sense, but in the literal lines of code sense? This is the simulation argument, a hypothesis that borders on science fiction yet is taken seriously by some of the brightest minds in physics and philosophy. The premise is simple. If a civilization could one day create simulations indistinguishable from reality, and if they chose to run countless such simulations, the odds that we're living in the original universe become vanishingly small. Statistically, we're more likely to be digital ghosts in someone else's machine. The idea gained traction thanks to figures like Oxford philosopher Nick Bostrom, who laid out the logic with chilling precision. For the simulation argument to hold, three possibilities exist. Either advanced civilizations never reach the capability to create such simulations, they reach that capability but choose not to run them, or we're almost certainly living in one right now. The first two options feel uncomfortably optimistic. Human history suggests that if a technology can be developed, it will be, often with reckless abandon. So why wouldn't a post-human civilization with unfathomable computing power spin up countless simulated worlds to study history, entertain themselves, or even preserve lost cultures like cosmic museums? This raises existential questions that sting. If we're simulated, does free will exist, or are we following a predetermined script? Are our emotions, our loves and losses just algorithms playing out? Some theorists suggest glitches in reality, déjà vu, quantum anomalies, even dreams, could be artifacts of imperfect code. Others counter that a flawless simulation would leave no traces, making the hypothesis unfalsifiable. After all, if the programmers wanted us to doubt our reality, they could have coded that doubt into us. But here's the twist: the simulation argument isn't just a nihilistic thought experiment. It could explain some of physics' deepest mysteries. Why does the universe operate on mathematical rules? Because math is the language of the simulation's code. Why is there a speed of light limit? That's the processor's maximum rendering speed. Even quantum indeterminacy, the idea particles don't have definite states until observed, makes eerie sense if the simulation only renders details when needed to save computational resources. The most haunting implication isn't about our reality's nature, but our place in it. If we're simulations, our creators might be simulations too. nested in an infinite regression of virtual worlds like cosmic matryoshka dolls. Or perhaps we're an abandoned experiment left running in some forgotten server farm of a long-dead civilization. The universe's silence, the Fermi Paradox we discussed earlier, could have a grim new explanation. No one's out there because no one was ever real to begin with. Yet for all its bleakness, the simulation hypothesis carries a strange comfort. If this is a simulation, its creators clearly wanted it rich enough to produce minds capable of questioning it. That means curiosity, beauty, and meaning might be baked into the system's design, not accidents but features. So the next time you watch a sunset or feel the weight of a difficult choice, remember, even if it's all code, the experience is no less profound. After all, what's reality but the one thing we all agree feels real? The universe is unimaginably old, 13.8 billion years of stars flaring to life and dying, of planets forming and cooling. Given that staggering time frame, you'd expect the cosmos to be teeming with civilizations crisscrossing the galaxy, building megastructures, filling the void with signals. And yet, as we've seen, the silence is deafening. One chilling explanation for this cosmic loneliness is something called the Great Filter, a hypothetical barrier, a wall so formidable that almost no life can climb over it. The terrifying question isn't just what the filter is, it's where it lies. Is it behind us, something we've already survived, making humanity a rare fluke in a sterile universe? Or is it still ahead, lurking in our future like a shadow we haven't yet seen? If the filter is in our past, we might be among the first or only intelligent beings to emerge. Maybe the leap from simple chemistry to self-replicating life is so astronomically unlikely that Earth won the ultimate lottery. Or perhaps multicellular life is the real bottleneck, a hurdle most planets never clear. Think about it, for over 2 billion years, Earth hosted nothing but single-celled organisms. The emergence of complex life required a perfect storm of conditions: oxygen levels, stable climates, genetic accidents that might be vanishingly rare. If that's the Great Filter, it means the universe is a graveyard of dead microbes with no one to mourn them. But there's a darker possibility, one that keeps astronomers awake at night. What if the filter isn't behind us but ahead? What if every civilization that reaches our level of technological maturity inevitably meets some catastrophic fate? The candidates are grim: nuclear war, runaway AI, ecological collapse, bioengineered plagues, even self-destructive social systems. The unsettling truth is we're already flirting with many of these existential risks. Our technology is advancing exponentially, but our wisdom isn't keeping pace. The same tools that could propel us to the stars could just as easily erase us from existence. Here's the twist: the Great Filter might not be a single event, but a gauntlet of traps. Maybe civilizations have to survive multiple near-extinction events before reaching interstellar adulthood. Climate change, pandemics, asteroid impacts, each one a potential stumbling block. And if even one is insurmountable, the universe remains silent, the terrifying implication. Every civilization that fails to pass the filter is a warning we'll never hear. This isn't just abstract doom-mongering. The Great Filter forces us to confront the fragility of intelligence itself. Every time we discover a new exoplanet in the habitable zone, every time we detect potential biosignatures in a distant atmosphere, the question lingers: did they make it? Or are we looking at a graveyard? The silence of the cosmos might be the loudest alarm bell we'll ever hear, a reminder that intelligence, for all its brilliance, might be nature's most ephemeral experiment. And so we're left in a race against ourselves. Either we've already beaten staggering odds, or we're standing on a precipice staring into the abyss. The Great Filter doesn't just explain the Fermi Paradox, it turns our search for alien life into a mirror, forcing us to ask the most urgent question of all. Are we the universe's great survivors, or just another civilization on the brink of joining the silence? The answer, whatever it is, changes everything. What if our universe isn't the only one? What if it's just a single page in an infinite cosmic library where every possible version of reality exists simultaneously? This isn't science fiction, it's the multiverse theory, a mind-bending idea that suggests our universe might be one of countless others, each with its own unique laws of physics, its own history, even its own version of you. Picture a bubble floating in an endless sea of foam. Each bubble is a separate universe, born from the same primordial soup but evolving in wildly different ways. Some might contain stars and planets like ours, while others could be so alien that matter as we know it never formed. In one universe, gravity might be 10 times stronger, crushing atoms into dust before life could begin. In another, the fundamental constants could be slightly tweaked, making chemistry impossible. And somewhere out there, in a reality almost identical to ours, you might have made a different choice this morning or never existed at all. The concept isn't just speculative fantasy. It emerges from legitimate physics like inflationary cosmology and string theory. When scientists trace the Big Bang backward, they find equations that suggest space-time didn't just inflate once, it could be eternally inflating, birthing new universes in an unending cascade. Quantum mechanics adds another layer. Every time a particle's fate is decided by probability, the universe might branch, creating parallel timelines where every possible outcome plays out. Here's where it gets even stranger. If the multiverse is real, there could be universes where time runs backward, where entropy decreases instead of increases, where cause and effect are reversed. Imagine waking up to watch shards of a broken cup leap from the floor and reassemble in your hand, or seeing sunlight flow into plants instead of out from them. These universes wouldn't just be different, they'd be incomprehensible to human logic. But the most haunting implication isn't the variety, it's the loneliness. If every possible universe exists, then every tragedy, every missed opportunity, every nightmare scenario also exists somewhere in the cosmic tapestry. There's a universe where dinosaurs never went extinct, where humanity never arose, where Earth was swallowed by a black hole before life could begin. The multiverse doesn't care about fairness or meaning. It's a machine generating endless permutations, indifferent to the stories playing out inside them. And yet, there's a strange comfort in this. If the multiverse is real, then somewhere out there, a version of you is living their best life. A version of Earth avoided climate disaster. A version of history where humanity reached the stars. The multiverse theory doesn't just challenge our place in reality, it obliterates the idea of a single, definitive reality altogether. We're not just small in space and time, we're small in the grand scheme of possibilities, one thread in a tapestry woven from infinite threads. So the next time you stare at the night sky, remember, you might not just be looking at distant stars, you might be glimpsing the edge of our cosmic bubble, beyond which lies an infinity of other universes, each with its own sky, its own mysteries, its own version of someone wondering if they're alone. The multiverse doesn't answer that question, it amplifies it, turning the silence of space into an echo of endless maybes. The universe isn't just expanding, it's slowly dying. Not with a bang, not with fire or ice, but with a whisper so faint we'll never even hear it. This is the heat death of the cosmos, the inevitable endgame of entropy, where all energy disperses into a silent, uniform void. Picture a cup of hot coffee left on the counter. At first, steam rises, warmth radiates, but given enough time, it cools to room temperature, its heat dissipated into the air until no trace remains. Now imagine that same principle applied to everything: stars, galaxies, even the particles that make up your body, all of it destined to reach the same lukewarm equilibrium. This isn't some distant, abstract doom. Entropy is already at work all around us, grinding down order into chaos. every time you shuffle a deck of cards, the chance of them returning to perfect order is astronomically small. The universe operates the same way, relentlessly moving from structure to randomness. Stars burn out, black holes evaporate, and over trillions upon trillions of years, even the last flickers of energy will fade. The cosmos won't end with a dramatic collapse or a fiery rebirth. It'll simply exhaust itself, like a clock winding down for the final time. Here's the cruel irony: the very forces that make life possible also guarantee its extinction. The uneven distribution of energy, the heat of stars, the chill of space is what allows complexity to arise. But entropy demands that those differences smooth out. Eventually, no star will be hot enough to power a planet. No atom will have the energy to bond with another. The universe will become a thin, lifeless soup where nothing happens because everywhere is the same. No storms, no currents, no gradients, just a stagnant sea of particles so spread out that they might as well not exist. Some theories suggest a way out, a loophole in this cosmic death sentence. Could intelligent beings stave off the end by harvesting the last scraps of energy? Could they create pocket universes or slip into higher dimensions? It's a beautiful thought, but the math is merciless. Even the most efficient civilizations would eventually run out of usable energy, their ingenuity no match for the relentless tide of entropy. The heat death isn't just an ending, it's the erasure of all possible endings, a finale so complete that not even stories of what came before will survive. And yet there's a strange solace in this inevitability. If the universe must end, let it be quiet, let it be gentle. No explosions, no suffering, just the slow dimming of a light that burned brilliantly for eons. We're here now, in the brief window when the cosmos is alight with possibility, when energy still flows and stories can be told. The heat death reminds us that time is precious, not because it's fleeting, but because it's the only chance we'll ever get to matter at all. On a quiet August night in 1977, a radio telescope in Ohio picked up a signal so extraordinary that the astronomer who discovered it scrawled, "Wow." In the margin of the printout, a burst of cosmic noise that still haunts the search for extraterrestrial intelligence to this day. For 72 seconds, the Big Ear telescope recorded a narrowband radio wave 30 times stronger than background noise, perfectly matching the predicted signature of an artificial transmission from deep space. Then, just as suddenly as it appeared, it vanished, never to be heard again despite decades of frantic searching. What made the wow signal so electrifying wasn't just its intensity, it was the frequency it used. The burst hit precisely at 1420 MHz, a protected band where earthly transmissions are forbidden, nestled in a quiet pocket of the spectrum ideal for interstellar communication. It's as if someone intentionally chose a cosmic calling card screaming, "We're here," and yet all attempts to trace its origin led to a chilling blank. No repeating pattern, no accompanying signal, not even a hint of a star system where it might have originated. The signal seemed to come from a patch of sky near the constellation Sagittarius, but that region holds no known exoplanets or advanced civilizations, just empty space and unanswered questions. Skeptics have tried to explain it away as a passing comet's hydrogen emission or a stray military transmission, but none of these theories fit the data. Comets don't produce such focused, powerful bursts, and human signals would have left traces in other telescopes. The WOW signal remains an enigma, a single flare in the cosmic dark that could have been anything from a natural anomaly we don't yet understand to the first and last message from a civilization far older than ours. Imagine standing on a shoreline at night, seeing a single flare arc across the horizon. Was it a distress call, a celebration, a random spark? You'll never know because the ocean gives no answers. That's the agonizing beauty of the WOW signal. Its fleeting nature leaves us forever wondering if we almost touched something extraordinary, or if the universe was simply playing a trick on us. For 72 seconds, the cosmos whispered. We just weren't listening closely enough to hear the rest. In the vast cosmic web where galaxies cluster like glittering cities, there exists a desert so immense it defies comprehension. The Boötes Void, a staggering emptiness stretching 330 million light-years across. If you dropped our Milky Way into this abyss, you'd need to travel tens of millions of years just to reach the nearest neighbor. A solitude so profound it makes the space between ordinary galaxies feel crowded. This isn't just a quiet corner of the universe, it's a gaping hole in the fabric of reality itself, and its very existence throws our understanding of cosmology into question. The Boötes Void was discovered in the early 1980s when astronomers mapping the cosmos noticed something bizarre, a region where galaxies simply vanished. Instead of the usual bustling clusters, they found only a handful of lonely stars adrift in an ocean of nothingness. At first, scientists assumed it was an error, a trick of incomplete data. But repeated observations confirmed the impossible, a void so vast it shouldn't exist under standard models of cosmic structure. The universe, after all, is supposed to be relatively uniform on large scales, like a sponge with evenly distributed holes. The Boötes Void isn't a hole. It's a chasm, a cosmic oversight that challenges everything we thought we knew. So what could carve such a void? One theory suggests it's the aftermath of an unimaginable collision between universes in the multiverse, a bruise left behind when our cosmos brushed against another. Others speculate it might be the work of an advanced civilization, a Kardashev-scale society that somehow harnessed the energy of entire galaxies, leaving behind a sterile playground. But the most unsettling possibility is that the void is just random, a statistical fluke in an infinite universe, a place where the dice of creation simply rolled empty. Here's the real mystery. Voids themselves aren't rare, but the Boötes Void is an outlier even among them. Most cosmic voids span 100 million light-years at most, contain at least some faint galaxies, and fit neatly into simulations of the universe's growth. Boötes defies those rules. Its sheer size suggests something fundamental is missing from our models. Perhaps dark energy behaves differently there, or some long-forgotten quantum fluctuation stunted its growth in the early universe. The void isn't just empty, it's too empty. In recent years, astronomers have painstakingly scoured it for missing galaxies, finding only 60 where there should be thousands. Those that remain are oddly clustered, as if huddling together for warmth in the cosmic dark. It's like stumbling upon a metropolis reduced to a single street lamp, the rest swallowed by shadows. Even the galaxies that do cling to life there show signs of starvation. Their gas, the raw material for new stars, seems to have been leached away by the void itself. Perhaps the most haunting lesson of the Boötes Void is how it humbles us. We like to think of the universe as predictable, governed by elegant equations. But then we peer into the abyss and find places that refuse to follow the rules. The void doesn't care about our models or our expectations. It simply is a silent reminder that for all our knowledge, the cosmos still holds pockets of profound unreason. It's not just a space between stars, it's a question mark written across the sky, daring us to explain it. And so the Boötes Void lingers, a cosmic ghost story without an ending. Is it evidence of forces we've yet to discover? A scar from a catastrophe we can't comprehend? Or just a cruel joke of probability? A reminder that even in an infinite universe, some things are meant to be lonely. Whatever the answer, one thing's certain. In the grand tapestry of existence, there are still threads we haven't found, and some, perhaps, that have been pulled loose entirely. In the cold, silent expanse beyond our solar system, two unmanned spacecraft, Pioneer 10 and Pioneer 11, began drifting off course in a way that defied every known law of physics. Launched in the early 1970s, these robotic explorers were meant to chart the outer planets before venturing into interstellar space. But as they sped farther from the sun, something strange happened. An unknown force, as subtle as it was relentless, began pulling them backward. Not enough to stop them, but enough to make NASA engineers double-check their calculations, then triple-check them before realizing the numbers weren't wrong. The probes were slowing down more than they should have been, as if space itself had invisible hands tugging at their edges. At first, scientists assumed it was a simple error, a fuel leak perhaps, or a glitch in the thrusters. But as the decades passed and the anomaly persisted, the mystery only deepened. The pioneers weren't just slowing down, they were decelerating at a rate of about 300 millionths of a meter per second squared. That's a force 10 billion times weaker than gravity's pull on Earth's surface, yet over interstellar distances it added up. By the time the probes were billions of miles away, their trajectories had shifted by hundreds of thousands of miles, a deviation impossible to ignore. Theories swirled like cosmic dust. Maybe it was heat radiation from the probe's own power systems, unevenly pushing against their surfaces. Maybe it was dark matter, invisible particles clustering around the spacecraft, adding unseen mass. Or perhaps it was something far stranger, a flaw in our understanding of gravity itself. The anomaly seemed to echo a controversial idea called modified Newtonian dynamics, or MUND, which suggests gravity behaves differently at extremely low accelerations. If true, it would upend Einstein's general relativity, rewriting the rules that have governed astrophysics for a century. Then, in 2012, a team of researchers announced they'd cracked the case. After poring over decades of data, they concluded the culprit was thermal recoil heat from the probe's radioisotope generators radiating off their dish-shaped antennae, creating a tiny but constant push. Case closed, or so it seemed, but skeptics pointed out that the math didn't quite add up. The thermal explanation accounted for most of the anomaly, but not all of it. A sliver of the mystery remained, like a ghost in the machine that refused to be exorcised. What makes the Pioneer anomaly so haunting isn't just the unsolved physics, it's the metaphor. These probes are humanity's first footsteps into the galaxy, messages in a bottle cast into the cosmic ocean. And yet, as they journeyed into the unknown, something we couldn't see or understand reached out and left fingerprints on them. It's a humbling reminder that even our boldest explorations are subject to forces beyond our comprehension, that the universe still keeps secrets in the spaces between the stars. The pioneers have long since fallen silent, their power sources drained, their signals faded into the background hum of the universe, but their anomaly lingers, a whisper from the void that challenges everything we think we know. Some mysteries don't get solved, they just drift deeper into the dark, waiting for someone, someday, to notice the next faint clue. The universe is supposed to be indifferent, random, a cosmic dice roll where no direction holds special significance. But when scientists mapped the afterglow of the Big Bang, they stumbled upon something that sent chills down the spines of cosmologists. The cosmos might have a preferred orientation, a ghostly axis that defies everything we thought we knew. They called it the axis of evil, a tongue-in-cheek name for a discovery so unsettling it threatens to upend our understanding of the universe's birth. This axis isn't some physical structure, it's a pattern buried in the cosmic microwave background, the faint echo of the Big Bang's heat. When researchers analyzed this relic radiation, they expected to find a universe that looked the same in all directions, a perfectly scrambled cosmic egg. Instead, the data revealed odd alignments, as if the universe had a subtle tilt, a lopsidedness that shouldn't exist. Temperature fluctuations in the radiation weren't entirely random. They seemed to whisper of a preferred direction, like a compass needle pointing toward some invisible north. The implications are profound. If the universe has an axis, it challenges the cornerstone of modern cosmology, the cosmological principle which states that on large scales, the cosmos should appear uniform in every direction. This principle is why we can assume the laws of physics work the same everywhere, why we trust that our corner of space isn't special, but the axis of evil suggests otherwise. It's as if we've spent centuries studying a vast, featureless desert, only to wake up one day and find footprints leading straight to our tent. So what could cause this eerie alignment? Some theorists propose it's a statistical fluke, a trick of the data that will vanish with better measurements. Others wonder if it's evidence of a pre-Big Bang structure, a shadow of some deeper reality that imprinted itself on our universe like a handprint in wet clay. The most radical idea that our universe isn't alone, that it's brushing up against another universe in the multiverse, their mutual gravity warping the cosmic microwave background like neighbors leaning on a shared fence. But here's the real conundrum. If the axis of evil is real, it doesn't just tweak our models, it tears them apart. The Big Bang was supposed to be the ultimate reset button, erasing any trace of what came before. Yet this axis lingers like a scar, a hint that the universe remembers something it shouldn't. It's a reminder that for all our telescopes and equations, we're still peering through a keyhole, catching glimpses of a room we've barely begun to explore. The name axis of evil might sound like hyperbole, but it captures the existential unease this discovery stirs. Science thrives on symmetry, on rules that hold everywhere. Finding an exception isn't just inconvenient, it's terrifying. Because if the universe isn't playing by the rules we've written, what else have we gotten wrong? The axis of evil isn't just a puzzle, it's a doorway, and on the other side might lie answers or questions we're not yet ready to ask. Have you ever been utterly convinced of a memory down to the smallest detail, only to discover the past has somehow rewritten itself? This phenomenon, known as the Mandela Effect, has left millions questioning the reliability of their own minds. Named after the widespread false memory of Nelson Mandela dying in prison during the 80s when in reality, he was released and became South Africa's president, this collective misremembering goes beyond simple forgetfulness. It's as if entire groups of people have stepped into subtly alternate versions of reality, carrying with them shared but incorrect recollections of everything from brand names to movie quotes. Take the Berenstain Bears, the beloved children's book series. Countless people swear the name was originally spelled Berenstein, with an E, a memory so vivid they can picture the bookshelf of their childhood bedroom displaying that very title. Yet every historical record shows it's always been Berenstain. The same goes for Darth Vader's famous line in Star Wars. Many recall him saying, "Luke, I am your father," when the actual quote is, "No, I am your father." These discrepancies aren't just typos or misquotes, they're deeply ingrained recollections that feel as real as any concrete fact. So what's happening here? Psychologists offer one explanation: false memories. Our brains aren't perfect archivists. They reconstruct past events on the fly, filling in gaps with plausible details. When multiple people share similar cultural touchstones like children's books or blockbuster films, these reconstructions can converge in eerily specific ways. The Berenstain era, for instance, might stem from the far more common Ein, ending in names like Einstein or Goldberg, making the incorrect version feel instinctively right. But the Mandela Effect has spawned far wilder theories. Some propose these glitches are evidence of parallel universes subtly overlapping, where alternate versions of events bleed into our collective consciousness. Imagine reality as a tapestry with countless threads, every decision, every possibility spinning off into its own timeline. Occasionally, those threads might brush against each other, leaving faint imprints of what could have been. In another universe, maybe the Bears really were the Berensteins, or Darth Vader did deliver that iconic line exactly as remembered. Others suggest something even more unsettling, that our reality might be a simulation, and these inconsistencies are like digital artifacts, glitches in the code where updates or patches weren't perfectly synchronized. Think of it as the universe's version of a software bug, where residual data from an older version lingers in some users' experiences. Regardless of the explanation, the Mandela Effect taps into a profound unease about how we perceive reality. It's one thing to misremember a detail alone. It's another to find an entire community sharing your mistake, down to the same misplaced letter or rewritten scene. These collective false memories force us to confront how fragile our grasp on the past truly is, not just individually, but as a species. After all, if we can't trust our shared history, what can we trust? Perhaps the most fascinating aspect isn't whether these alternate memories are real in a literal sense, but why they resonate so deeply. The Mandela Effect isn't just about spelling or movie quotes, it's about the stories we tell ourselves to make sense of the world. When those stories diverge from recorded fact, it creates a cognitive dissonance that feels almost supernatural. In the end, the effect may reveal less about parallel universes and more about humanity's craving for narrative coherence, the desperate, beautiful insistence that our memories, however flawed, are the anchors of our identity. And that might be the most unsettling truth of all. On certain clear nights, long after the sun has set but before dawn begins to creep over the horizon, you might spot something eerie, a faint, ghostly pillar of light rising from the horizon, glowing like a celestial ladder against the stars. This isn't some supernatural phenomenon or trick of the eyes. It's the Zodiacal Light, one of the sky's quietest and most mysterious spectacles. That ethereal glow comes from billions upon billions of dust particles scattered across our solar system, reflecting sunlight in the darkness of space. But here's what makes it truly unsettling. No one knows exactly where all that dust came from. For centuries, astronomers assumed these particles were simply the leftover debris from asteroid collisions or the trails of comets' cosmic breadcrumbs marking the violent encounters between celestial bodies. Yet when scientists measured the total volume of dust in the zodiacal cloud, the numbers didn't add up. There's too much of it, spread too evenly, for it to be just fragments of random space rocks. The sheer scale suggests something far more dramatic. This dust could be the shattered remains of an entire lost world, a planet that once orbited our sun but was torn apart long before humans ever looked up at the night sky. Imagine a Mars-sized planet billions of years ago, drifting too close to the gravitational chaos of the young solar system. Perhaps it collided with a neighbor or was ripped apart by tidal forces from a gas giant like Jupiter. Whatever the cause, its destruction would have flung an unimaginable volume of debris into orbit, creating a ring of dust so vast it still lingers today, painting the sky with the faint echo of its demise. Some researchers even speculate this phantom planet could be linked to Theia, the hypothesized world whose collision with early Earth is thought to have created the Moon. If true, the Zodiacal Light isn't just dust, it's the funeral shroud of a long-dead sibling to our own planet. But there's an alternative explanation, one that's no less unsettling. The dust could be streaming in from beyond our solar system, carried on the solar wind or drifting in from interstellar space like silent invaders. Recent observations suggest some of these particles move in ways that defy the gravity of our sun, hinting at an external origin. If that's the case, then the Zodiacal Light isn't just a relic of our past, it's a hint of something vast and unseen, a whisper of the greater galaxy pouring into our celestial neighborhood grain by grain. What makes the Zodiacal Light so haunting isn't just its origin, but what it represents, the impermanence of worlds. Whether it's the corpse of a lost planet or the slow accumulation of cosmic driftwood, it's a reminder that even the most solid-seeming things, planets, stars, even entire solar systems, are just temporary arrangements of matter. The universe is constantly recycling itself, grinding down the old to build the new. And that faint glow in the night sky is proof. Every time we see it, we're glimpsing the invisible machinery of existence, the endless cycle of creation and destruction playing out in slow motion. And so the Zodiacal Light lingers, a bridge between the known and the unknown. It's astronomy's oldest unanswered question written across the heavens, a puzzle wrapped in starlight. The next time you find yourself under a clear, moonless sky, look for that faint pyramid of light reaching upward. It's more than just dust, it's a message from the past waiting for us to decipher its secrets. Astronomers have a cosmic detective story on their hands, one where the evidence seems to contradict itself in ways that shake the foundations of physics. Imagine finding a grandparent older than their own grandchild. That's essentially what scientists face when they study certain stars in our universe, celestial elders whose estimated ages exceed the 13.8 billion years we've calculated for the cosmos itself. The most famous of these is Methuselah, a faint star in the constellation Libra, whose light tells a story at least 14.5 billion years old, nearly a full billion years older than the universe should be. It's like discovering a 500-year-old oak tree in a forest only 4 centuries old. The math doesn't just disagree, it defies logic. This paradox forces us to confront two unsettling possibilities. Either we've grossly miscalculated the universe's age, or our understanding of stellar physics is fundamentally flawed. The first option would mean rewriting the cosmic timeline we've built from meticulous observations of the cosmic microwave background, the faint afterglow of the Big Bang. The second is even more radical. It suggests stars might form, evolve, or burn fuel in ways we've never imagined, operating under hidden rules that bypass our current models. Take Methuselah's age estimate. Scientists determined it by analyzing the star's composition specifically, its shockingly low iron content. In the early universe, before generations of supernovas seeded space with heavy elements, stars were made almost entirely of hydrogen and helium. Methuselah's near-pristine state suggests it's a relic from this primordial era. But here's the catch. To fit within the accepted age of the universe, the star would need to have formed impossibly early, like a flower blooming in the first seconds of spring. There's a third, even wilder explanation, one that whispers of multiple universes. Could Methuselah be a refugee from a previous cosmic cycle, a survivor of a Big Bang that wasn't ours? Some models of eternal inflation suggest universes might bubble up and collide in an infinite multiverse, occasionally spilling material between them. If true, our cosmic ancestry could be far stranger than we've dared to imagine. But the plot thickens beyond this single star. Globular clusters, dense spheres of ancient stars orbiting the Milky Way, also present age estimates pushing the limits of our cosmic calendar. Their intricate dances and chemical fingerprints suggest formations 12 to 13 billion years ago, leaving barely 500 million years for the universe to cool, structure itself, and birth these stellar cities, an unrealistically tight squeeze. So where does this leave us? With humility, mostly. The universe keeps a few cards close to its chest, revealing just enough to remind us how much we don't know. Every time we think we've pinned down the cosmic timeline, an ancient star winks back at us, its light carrying secrets we're not yet equipped to decipher. The real lesson here isn't just about dates and decimals. It's about the flexibility of truth in an ever-expanding cosmos, where even the most fundamental facts might be waiting to be rewritten. These 22 unsettling truths remind us that the universe isn't just bigger than we imagined, it's more bizarre, more mysterious, and more humbling than even our wildest theories dared to predict. We've journeyed through cosmic shadows where time bends, particles whisper across light years, and entire galaxies vanish into voids. We've grappled with invisible forces that shape existence, pondered whether we're alone or merely lines in someone else's code, and stared into the abyss of a future where reality itself might unravel. Yet for all we've uncovered, the cosmos still holds its deepest secrets close, revealing just enough to keep us forever searching. What makes these mysteries so compelling isn't just their complexity, it's the way they challenge our place in the grand scheme. We're not passive observers of some orderly clockwork universe. We're wanderers in a labyrinth where the walls shift when we're not looking. Every answer spawns new questions. Every discovery peels back another layer of the unknown. The more we learn, the more we realize how much lies beyond the edges of our understanding. But here's the beautiful paradox. The universe's strangeness isn't a barrier, it's an invitation. Each unsolved riddle, from the whispers of dark matter to the silence between the stars, is a beacon calling us to look deeper, think braver, and imagine brighter. Science isn't about having all the answers, it's about having the courage to keep asking better questions. So what do you think? Did one of these cosmic enigmas unsettle you the most? Maybe the idea of a Boltzmann brain made you side-eye reality, or the Great Attractor's pull left you feeling like a leaf caught in a galactic current. Drop your thoughts in the comments. I'd love to hear which mystery haunted your imagination. And if you're hungry for more deep dives into the universe's greatest puzzles, don't forget to subscribe. The cosmos has endless stories left to tell, and we're just getting started. Until next time, keep looking up and wondering what's looking